Welcome back. This is an Aleks training video on writing the electron configuration of a first transition series atom. As we've been learning the electron configurations, you fill them in order of lower energy. The cheap rooms go first, and the expensive rooms only are filled when there's no other choice. There's a couple weirdnesses in that first row of transition elements. So normally the transition elements between scandium and zinc, let me give you a periodic table. Okay, between scandium and zinc would be 3Ds. So you would have 4s1, 4s2, 3d1, 3d2, 3d3, 3d4, all the way up to 3d10. So there are two of them that are a little bit weird. Chromium and copper. Chromium and copper are slightly different. Instead of 4s1, 4s2, 3d1, 3d2, 3d3, what's happening is, look at this. Zinc would be a full subshell. Well, manganese would be a half-filled subshell. Remember when we did the octet rule and I taught you that everything wants to have an octet equal to a noble gas configuration where it's a full shell? This is over in the noble gas. Everybody wants it, and so they'll steal electrons to get it, or they'll give away electrons to get it because they want that stability of that full shell. Well, it works that way all the time with electrons. Electrons really want to have a shell filled because it's more stable than something else. So in the case of copper, okay, copper should have 2 s electrons and then 9 d electrons. Well, for whatever reason, electronically, more stability is to steal one of the s electrons and put it in the d and fill the d. They would rather borrow one of their s's and fill the d than have the s subshell filled. It's more stable for them sometimes to do that. So copper will sometimes steal and chromium will steal. So this is a half subshell. This is rather, it's enough energy to steal one from the calcium to stick it in the manganese slot, even though that they don't have enough to fill them both. They would rather this be full than this. So let me give you the two configurations. If you're going to have chromium, okay, chromium, you'll have argon, and it'll go from argon to 4s, it should be 2, but they're going to steal one of the s's, and so there'll only be 4s1, and then it'll go to, instead of 3d4, it'll go up to 3d5. Okay, so what you expect is argon 4s2, 3d4. Okay, you're not going to see that. Likewise with copper, even more so with copper, I guess, it's argon, and it should be argon 4s2, 3d9. But you're not going to see that. You'll see instead 4s1, 3d10. Sorry, 3d10. 4s1, 3d10. These are your two exceptions. Anything that's not chromium and copper on this line is just going to be normal. Okay, so vanadium, if you look at vanadium, vanadium is scandium, titanium, vanadium, so it's the third of the Ds. So you're going to have, you'll have argon configuration plus 4s2 plus 3d3. Okay, no problem. With titanium, it'll be the same. argon. See, titanium is next. Titanium, or it's before actually, it would be 3d2. Titanium would be 4s2, 3d2. Okay, so chromium would have if it steals one from its S, it'll have a half shell filled. It's somehow a little more stable. And copper, if it steals one of its S's to make it full, it would rather have its D filled than its S filled. Okay, so these are a little weird. The rest of them are normal. Thanks.